All right, let's talk about something that is, no joke, one of the most critical principles for building any application that you want to scale. I'm talking about this stateless web tier. And trust me, once you really get this concept, it'll completely change the way you look at system architecture.
So, you know that feeling, right? You're using an app or a website, it works great, it gets super popular, and then it just starts to fall apart. It crashes when you're trying to check out, it logs you out for no reason. Well, there's a really common reason for that, and we're going to tear it down.
And that reason, the real villain in this story, is what I call the stateful server trap. Now, it seems like a perfectly fine way to build things when you're starting out, but it sets a trap that can bring a whole growing service to its knees.
At first, a stateful architecture seems totally logical. I mean, you log in, you add something to your shopping cart, and the server you happen to be connected to just remembers you. It keeps all your session info right there on its own hard drive. It knows who you are from one click to the next. It feels simple, but that simplicity is hiding a huge problem.
And here's the problem. Because that server is the only one that remembers you, every single request you make has to go back to that exact same machine. This is done with something called sticky sessions, which basically glues you to one server. And sticky is the right word because now you're stuck.
So what happens when the one server you're stuck to has a problem? What happens when it forgets you? To really see the risk here, let's use a super simple analogy.
This just nails it. A stateful server is like a bank where only one specific teller, let's call him Bob, knows you. He's got all your info in his head. If Bob goes on lunch or calls in sick, you're completely stuck. Nobody else can help you. A stateless server? That's a modern bank. Any teller can help because they can all just pull up your account on the central computer system.
Okay, let's actually watch this break in real time. We've got a load balancer sending users to different servers, but with sticky sessions, each user is now glued to a specific machine. User B's entire session lives only on server 2. So what happens when server 2, inevitably crashes? Watch this. Bam! The server goes down. And because it was the only one that knew about user B, poof, their session is just gone, they're logged out, their cart is empty, their experience is ruined. And this isn't some theoretical tech problem. This is a real, super frustrating thing that we have all felt. You lose all your work, you get kicked out of a service. It's almost always a direct result of this stateful server trap. But there is a much, much better way. So let's introduce the hero of our story, the stateless solution. This is the pattern that solves these problems and unlocks real, massive scale.
In a stateless world, the web servers are totally different. They're basically generic, interchangeable workers. Not a single one of them holds on to your session data locally. They don't have to remember you because that's not their job anymore.
Which, of course, leads to the most important question. If the web server doesn't have my session data, where in the world did it go?
We move it. We pull the state, your login, your shopping cart, all of it, out of the web tier completely. We put it into a separate, centralized, really fast data store that all of the web servers can talk to. This is usually something like an in-memory cache like Redis or a specialized database.
Now let's replay that exact same crash, but this time with our new stateless design. The user's first request hits server 1. It just pulls the session from that central store. Now let's crash server 1. But watch what happens. It doesn't matter. The load balancer just goes, oh, okay, I'll send you over to server 3. Server 3 then pulls the exact same session from the shared store and just keeps going. The user has no idea anything bad even happened. It's totally invisible.
And that seamless failover, that's just the beginning. By separating the state from the web tier, we unlock some incredible superpowers for our application.
This design directly fixes everything that was wrong before. First, you get seamless horizontal scaling. Need to handle more traffic? Just add more generic servers to the pool. That's it. Second, you get true high availability. Like we just saw, a server can just die and the system keeps on working. The whole thing is more robust, more resilient, and way, way easier to manage.
So if you only take one single thing away from this explainer, let it be this. This is the golden rule for building scalable apps. Keep your web tier stateless. You want to treat your web servers like cattle, not pets. They should be completely interchangeable, not these unique things holding critical data.
And that leaves us with one final thought. The architecture you're building, or the systems you use every day, are they actually designed for growth? Are they built to scale, or are they built on a foundation that's just waiting to fail? So often, the answer to that question comes down to state.